The surprising part is not that AI can talk. It is that talking is the easy bit. The hard part is getting software to act safely, repeatedly, and under permission. Once you let a system touch real tools, every small mistake can compound. Agentic operating layers are the shift from prompt and response to delegated work with memory. These systems plan steps, call tools, track state, absorb feedback, and finish bounded workflows. They also do it under constraints, like explainability, audit trails, and governance rules. In practice, that means an agent is less like a personality and more like an operating layer. It sits between intent and execution. A useful mental model comes from sequential decision-making. An agent holds a policy, it chooses an action, the action changes the environment, then feedback updates future behavior. That loop sounds clean, but real deployments are messy. Each step changes what the next step even means. Errors do not just happen, they accumulate. A wrong tool call early on can make later steps look consistent, while still being wrong overall. So reliability is not a single model property. Reliability is a systems property. Deployed AI is a modular software stack, not a single autonomous mind. You have data pipelines, retrieval surfaces, model components, tool interfaces, logging, evaluation harnesses, and approval boundaries. When leaders ask, "Is the model safe?" the practical answer is, "Show me the whole stack." The stack determines what the system can reach, what it can change, and what it must prove. That is why explainability matters, but also why it can mislead. Explanation methods can produce narratives, saliency maps, rationales, and other artifacts that feel satisfying. Yet those artifacts do not prove correctness, intent, or causality. They do not guarantee safe delegation. In high-consequence settings, explanations are governance tools, not truth machines. They can help an operator notice a failure mode. They can also create false confidence if they look coherent while the system is drifting. A second insight is about tools, not language. Agentic layers must interface with heterogeneous services, sensors, databases, and event streams. The best precedent is not a chatbot. It is an Internet of Things architecture. IoT systems taught engineers what happens when you connect many devices and services, each with its own failure modes. Interfaces change over time. Event streams arrive out of order. Authentication fails. One dependency goes stale, and the system keeps running, but now on partial truth. That heterogeneity forces a design discipline. Tool calls need to be typed and bounded. State changes need to be observable. Every action should be tied to an identity and recorded in logs that can be audited later. Without that, you do not have delegation. You have plausible deniability wrapped in automation. The agent did something, but nobody can reconstruct what happened or who owned the decision. Memory becomes the quiet battleground here. A chat system can forget, and the worst outcome is a bad answer. An agentic layer cannot casually forget. It has to decide what task state to retain, what to summarize, what to cluster, and what to discard. Memory is also a security surface. Retained state can leak data. Forgotten state can cause repeated errors. Summarized state can hide the details needed for an audit. Clustering, a classic computational primitive, shows up as more than an academic footnote. You can use it to organize long histories into manageable groups. You can cluster telemetry to detect anomalies, or segment workflows by patterns of failure. When you run many agents, you need a way to see the system as a fleet. Clustering helps you spot which tasks are stable and which are quietly degrading. Domain specialization is another counterintuitive point for strategy leaders. General conversational competence is not the same as competence inside a regulated domain. Specialized representations can outperform generic chat in narrow environments. A concrete precedent comes from biomedical language models, where domain-adapted training improved text mining performance. The lesson is broader than medicine. If your workflows have specialized vocabulary, specialized document structures, and specialized consequences, you should expect specialized agent layers, not one universal assistant. Now consider human language itself as a command surface. Fluent language can trick us. Speech production theory reminds us that generating words is a staged process, optimized for communication, not for guaranteed correctness. An AI system that produces fluent plans is still just producing language. Execution requires interpretation, authorization, and validation. That separation should shape governance. You want strong walls between what the system can say and what the system can do. The most promising safety lever is decomposition into machine-checkable subroutines. Not every task can be formally verified, but some parts can. Formal proof tools in mathematics demonstrate a style of workflow where outputs are checked, not merely explained. Translate that idea into operations. Wherever possible, structure high-consequence work so an agent proposes, then a validator checks, then a controlled tool commits. The validator might be a formal system, a constrained schema, a reconciliation check, or a deterministic policy engine. The key is that some steps produce evidence, not stories. Robustness is the final practical constraint leaders tend to underestimate. Deep learning systems remain sensitive to data distributions, architecture choices, and evaluation discipline. In the real world, inputs vary. Documents come in new formats. Interfaces add fields. Even minor variation can break perception and retrieval. Data augmentation research is one reminder that robustness must be engineered, tested, and monitored. You do not deploy once. You deploy, measure, retrain, and redesign the boundaries. Put these pieces together, and a timeline emerges that is more about institutions than about magic. The near band, from 2026 to 2050, is decisive for bounded deployment in enterprise and government. Success will hinge on permission design and auditability, not on ever more charming conversation. The mid-band, 2050 to 2100, determines whether delegation becomes standardized infrastructure or remains fragmented workflow automation. Farther out, agentic layers could become part of institutional memory and administrative control planes, but only if trust infrastructure endures. That trust infrastructure has a familiar shape to anyone who runs critical systems. Identity, permissioning, provenance, audit retention, evaluation, and revocation are not optional add-ons. They are the substrate. Without them, you cannot assign authority, reverse mistakes, or allocate liability. With them, you can start small, in workflows where every machine action is reversible, logged, and owned by a named human role. So the near-term decision is not whether to adopt agents. The real decision is which actions machines are allowed to perform, under whose authority, with what evidence record, and with what rollback plan. Treat agentic operating layers as control plane infrastructure, and you will earn the right to delegate. Treat them as chatbots with tool access, and you will eventually fund an incident you cannot explain.